In section 4.4, we're going to be talking about properties of logarithms. If you look in the box, we have our three different properties. This one just says if you have an exponent, we can pull it out front and write it as a coefficient in front of logarithm, or you can vice versa. You take it from out front and you can write it as an exponent. The second property says if it's a multiplication right here, you can rewrite it as addition. And if this is a division, you can rewrite it using subtraction. So we're going to look at that in this first part and use these properties. So in number one, this is an exponent, so I can move that out front and this becomes 2 log of 3, log base 3 of a. Okay, number two, this shows multiplication. That means I can rewrite it as addition. I break it off, log base b of 5 plus log base b of x. And number three, if it's division right here, and I can rewrite it as subtraction. So I'm going to say log base b of x minus log base b of 3. So that's just using very basic concepts of these properties introduced there. On the next page, these are the same properties listed. We're going to continue writing these, continue working some. This is log of 5x. A square root really means x to the 1/2 power. It can be rewritten as that. So now I can use this property where my exponent can come out front. So it's 1/2 log base 5 of x. This next one, the first thing I want to do on number 5 is this is multiplication. So I'm going to rewrite it log base b of x to the third plus, because it's multiplication, log base b of y squared. Now I can also use my exponent property and use my powers, bring those out front, so I can get 3 log base b of x plus 2 log base b of y and rewrite that. Likewise in number 6, the numerator, this and that's multiplication, so log base b of x squared plus log base b of y, that's because of multiplication. Now the z is division, so I'm going to do subtraction for log base b of z. Now I can, any of my exponents, I can move out front, so this is 2 log base b of x plus log base b of y minus log base b of z. Whoops. So that's going to be that one. Now we're going to move on to the next page, which it says express as a single logarithm and simplify if possible. So we're going to kind of work backwards. If it's addition, I can rewrite it using multiplication. So I have log base b, they have the same base, they have to be, and it's plus, so I'm going to rewrite it using the multiplication. And the next one, this is going to be multiplication, and this is going to represent a division, so I'm going to have log base b of x and then y. This 2 gets to come right here as an exponent, so that's y squared over, and because of subtraction, it's going to be a z. So I'm going to sum that up one more time. This plus tells me I can multiply this x and this y. Okay, that's why I have x and y in the top. Now this 2 can be moved to be an exponent, so that's why I have my y squared. And then subtraction means divide by z. Okay, my next one, I'm going to move this as an exponent. I'm going to move this as an exponent, so I'm going to get log of 6x to the 1/2 power is the square root of x, and then plus log base 6 of y squared minus log base 6 of z. Now I'm going to multiply these first two and divide for the next one. So overall I get log base 6 of, I'm going to use the square root of x times y squared all over z. So be able to use these properties forward and backwards from logarithms and then simplifying and vice versa.